There has been a battle going on. There has been an information battle. Do you believe or do you not believe? That is the question. And if you choose to believe, what is the consequences of that belief? Are you prepared for what the truth may be? Is mankind prepared for what the truth may be? This is what we will be exploring in this series known as Beyond Undisclosed.
The propulsion that has set all world records for distance remains top secret. Electrogravitic propulsion is a theoretical concept that has been under investigation by researchers and scientists for several decades. It involves the use of electromagnetic fields to create a force that can overcome gravity and propel a spacecraft. While there is much debate about the feasibility and effectiveness of electrogravitic propulsion, it remains an exciting area of research and could potentially revolutionize space exploration. In this essay, we will explore the history and current state of electrogravitic propulsion, beginning with a basic overview and progressing to an expert-level description. Basic overview. Electrogravitic propulsion is a type of propulsion system that uses an electromagnetic field to produce thrust. The idea behind electrogravitic propulsion is that by creating a strong electromagnetic field around a spacecraft, it can be made to lift or move in a specific direction. This is accomplished by the interaction between the electromagnetic field and the gravitational field of the Earth or other celestial bodies. The concept of electrogravitic propulsion is based on the theories of electromagnetism and gravity. Electromagnetism is the study of the interaction between electrically charged particles, while gravity is the force that attracts objects with mass to each other. The idea behind electrogravitic propulsion is to harness the power of these two fundamental forces to create a propulsion system that is more efficient and effective than traditional chemical rockets. One of the most well-known proponents of electrogravitic propulsion is the late scientist and inventor, Thomas Townsend Brown. Brown first proposed the idea of electrogravitics in the 1920s, and his work laid the foundation for much of the research that has been done in this field. Brown believed that by applying a high voltage to a capacitor, it could create a gravitational effect that would cause the capacitor to move in a specific direction. Brown's experiments were controversial and met with skepticism from many in the scientific community. However, his work inspired others to continue exploring the possibilities of electrogravitic propulsion. Over the years, several different theories and approaches to electrogravitics have been developed, each with its own strengths and weaknesses. Intermediate overview. To understand electrogravitic propulsion at an intermediate level, we need to delve deeper into the physics behind the concept. At its core, electrogravitics is based on the interaction between electric fields and gravitational fields. An electric field is created when there is a difference in electric potential between 2 points. This potential difference can be created by applying a voltage to a conductor or by the separation of electric charges. A gravitational field, on the other hand, is created by the presence of mass. The greater the mass of an object, the stronger its gravitational field. In electrogravitic propulsion, an electromagnetic field is created by applying a high voltage to a capacitor or other electrical device. This electromagnetic field can then interact with the gravitational field of a nearby celestial body, such as the Earth. The interaction between these two fields can create a force that causes the spacecraft to move in a specific direction. The exact mechanism behind electrogravitic propulsion is still a subject of debate among scientists and researchers. Some believe that the force created by the interaction between the electromagnetic and gravitational fields is a result of a reduction in the spacecraft's mass. Others believe that the force is due to a change in the curvature of space-time caused by the electromagnetic field. One of the challenges in developing an electrogravitic propulsion system is the amount of power required to create a strong electromagnetic field. The voltage required to create a strong enough field can be in the millions of volts, which presents significant engineering challenges. Another challenge is the fact that the force generated by electrogravitics is relatively weak compared to other propulsion systems, such as chemical rockets. Expert level overview. At an expert level, electrogravitic propulsion is a complex and multidisciplinary field that involves advanced concepts in physics, engineering, and materials science. To understand electrogravitic propulsion at this level, we need to look at the equations that describe the interaction between electric and gravitational fields. The force experienced by a charged particle in an electric field is given by the equation F equals QE, where F is the force, Q is the charge of the particle, and E is the strength of the electric field. Similarly, the force experienced by an object due to gravity is given by the equation F equals mg, where F is the force, m is the mass of the object, and g is the acceleration due to gravity. In electrogravitic propulsion, the force created by the interaction between the electromagnetic and gravitational fields is given by the equation F equals QE, mg. This equation shows that the force experienced by the spacecraft is dependent on the strength of the electric field, the charge of the spacecraft, and the mass of the spacecraft. To create a strong enough electric field, a high voltage is required. The voltage required can be calculated using the equation V equals ED, where V is the voltage, E is the strength of the electric field, and D is the distance between the electrodes. For example, if we want to create an electric field of 1000 volts per meter over a distance of 1 meter, we would need a voltage of 1000 volts. One of the challenges in developing an electrogravitic propulsion system is the amount of power required to create a strong enough electromagnetic field. The power required can be calculated using the equation P equals 4, where P is the power, I is the current, and V is the voltage. For example, if we want to create a voltage of 1000 volts with a current of 1 ampere, we would need a power of 1000 watts. Despite the challenges, electrogravitic propulsion remains an exciting area of research, with potential applications in space exploration. The Voyager spacecraft, launched in 1977, uses a form of electrogravitic propulsion known as the radioisotope thermoelectric generator, RTG. The RTG generates electricity by converting the heat produced by the decay of radioactive isotopes into electrical power. This power is used to create an electric field, which is then used to control the orientation of the spacecraft. The Voyager spacecraft has been instrumental in advancing our understanding of the outer solar system. It has visited Jupiter, Saturn, Uranus, and Neptune, and is currently on its way out of the solar system. The Voyager spacecraft has exceeded all expectations, and its success is a testament to the ingenuity and determination of the scientists and engineers who designed and built it. Conclusion. In conclusion, electrogravitic propulsion is a theoretical concept that has the potential to revolutionize space exploration. It involves the use of electromagnetic fields to create a force that can overcome gravity and propel a spacecraft. While the concept is still in its early stages of development, there have been significant advancements in the field, and it remains an exciting area of research. To understand electrogravitic propulsion at an expert level, one must have a deep understanding of the physics and engineering principles involved. The equations that describe the interaction between electric and gravitational fields play a critical role in the development of electrogravitic propulsion systems. While there are many challenges that must be overcome before electrogravitic propulsion becomes a viable option for space travel, the potential benefits are too great to ignore. The Voyager spacecraft is a testament to the potential of electrogravitic propulsion, and its success should inspire future generations of scientists and engineers to continue pushing the boundaries of what is possible.